Okay, everyone, we're going to go back to binary code. And remember, last time we talked about binary code, we talked about how our characters or letters represented in binary. And remember, binary code is basically a numbering system, or it's a character system. It's a numbering system that only uses 0 and 1. And so everything must be represented in 0 and 1 on a computer because, as we learned with circuits, a 1 will enable a circuit, a 0 will not enable a circuit, and that's how everything is processed in a computer. So there are many kinds of numbering systems. We usually work with a decimal system. That's what we usually use in math. But there's also a binary numbering system. And every number can be converted into a binary number. So normally numbers are, let's say we have 25 or 100, 1,862. We have to, what we're going to be learning is how do we write those numbers just using a 0 and a 1. And we're going to go through that. So any number, decimal, fractions, positive or negative, can be represented by the binary system. Okay, so let's take a look at the difference between decimal and binary. In a decimal system, it's base 10. In a binary system, it's only base 2. In a decimal system, we can use all these numbers, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. In a binary numbering system, we can only use 0 and 1. In the decimal system, the place values are ones, tens, hundreds, thousands, etc. In a binary numbering system, we have ones, and then there's twos, fours. Let me go back. These are the place values. So 1, 2, 4, 8, 16, 32, etc. So if we look at the base here, this would be 10 to the 0, 10 to the first, 10 squared, 10 cubed, etc. In a binary system, this would be 2 to the 0, 2 to the 1, 2 squared, 2 cubed, 2 to the fourth, 2 to the fifth, etc. Okay, so here's an example of a regular decimal number, 3,745. The way we really identify this is the ones place, this is the tens, hundreds, and the thousands. So when I figure out the value of this number, I start with the ones. There's 5 in the ones position, so that's 5. There's 4 in the tens position, so that's 40. There's 7 in the hundreds position, so that's 700. And there's 3 in the thousands position, so that's 3,000. And if we add all these numbers up, we get 3,745. We do the same exact thing in a binary system. So instead of 1, 10, 100, 1,000, it's going to be 1, 2, 4, 8, 16, 32. And so wherever there's a 1, then that place value has a value. And where there's zeros, there isn't any. So for example, here on the ones, we have a 1, a 2, a 4. We don't have an 8 or a 16, but we have a 32. So if we look at this, if we add these numbers up, wherever there's a 1, a 32 plus 4 plus 2 plus 1, we get 39. So 100,111 is equal to 39. Okay, so the first thing we're going to do is I'm going to give you some binary numbers, and you're going to find the decimal equivalents. And the way we do that is we first write down this table, and on this table we have the place values, 1, 2, 4, 8, 16, 32, 64, and we're just going to go up to 128. So this is 1 byte. So if I give you, for example, this binary number, 0000, 1011, you have to find out what is this decimal, what is this binary number as a decimal. And the way you do that is wherever there's a 1, you add the corresponding place value. So for this number, this binary number, for us to figure it out what's the decimal, we're going to add a 1, a 2, and an 8. And that's it. We don't add any of the ones with the 0. So if I add 1, 2, and 8, I get 11. So 0, 0, 0, 0, 1, 0, 1, 1 is the equivalence of 11, or that is 11 in decimal. Let's see another example. 0, 0, 1, 1, 1, 0, 0. And if I wanted to know what is the decimal equivalent for this binary number, I find all the ones. So this would be a 4 plus 8 plus 16. So 4 plus 8 plus 16 would be 28. And all the zeros, I don't have to count them in. Okay, I'll do another one. Here's another one. Again, we just count up where there's ones. So there's a 1, there's a 2, a 4, an 8, and a 32. So I'm going to add up 32 plus 8, which is 40, plus 44, plus 4 is 44, plus 2 is 46, and 1 is 47. And that's what that is. All right, and I'm going to give you one last one. I'd like you guys to try it. Find the where the ones are, count those place values, add them up, and what do you get? Okay, for this one, it's 128 plus 32 plus 1, and so it's 161. And here's the last one. And what you get is 64 plus 32 plus 4 plus 2, and that's equivalent to it. That's 102. So again, this binary number 011001110 is really 102. So when I am working on a computer and I want to use this number 102, it's translated into binary code first and then processed. All right, so now that we've gone from, if you have a binary number and we have to find the decimal number, we're going to go the other way. If I have a decimal number, how do I write that in binary? And the way you do that is you want to start from the higher place values, and then so you're going to go from left, the higher place values, to the right, which are the lower place values. And what you do is you check, is the decimal number greater than the place value? If it is, then you use a 1 for that place value, and then you subtract the place value from the decimal number, and you continue down the sequence of place values. If the decimal number is smaller than the place value, then you use a 0. So here's an example. For example, I want to find the binary number for 40. I want to know how to write 40 just using 1s and 0s. So I'm going to start, again, we're just using up to 128. I go to my table, which I'm going to show in a little bit, and I start with the place value for 128. Is there 128 in 40? And the answer is no. 40 is a lot smaller number, so I would use a 0 for that 128 place value. Then I go to 64. Is there 64 in 40? No. It's still too high, so I use a 0 for the 64 place value. Is there 32 in 40? Yes. Now notice the difference here. 32 is a smaller number than 40. So I can get 32 out of 40. So I put a 1 in the place value for 32, and I subtract. 40 minus 32 is 8. So I've already represented 32 out of the 40. All I need is 8 more. I go down to 16. Is there 16 in 8? It's too much. I only need 8, so 16 I use a 0. Then I go down to 8. Is there 8 in 8? Yes, it's exactly the right amount. So I'll use a 1 in the 8 for the place value of 8 and subtract 8 from 8 and I get a 0. So that's pretty much it. I don't need the 4, the 2, and the 1. Again, here's one to write the binary number for 50. And I do it the same way. I start with 128. 50 is too small, it's much smaller than 128. I don't need 128, so I put a 0. I don't need a 64, I put a 0. I will take a 32, so I put a 1 there. I subtract. 50 minus 32 is 18, so that's how much I have left. Is there 16 in 18? Yes. So I'll take a 16 as well. So I put a 1 in that 16 place value, and I subtract 18 minus 16. I have 2 left. So I don't need the 8. I don't need the 4, but I do need the 2 place value. So I put a 1 in that one, and I don't need the 1. So here's an example for both of them. For the 50, remember I used 32, 16, and 2. And I put zeros in all the other ones. So for the 50, the way you represent it in binary is you'd say 0011, 0010. And for 40, remember we just used 32 and 8. Those are the only ones that have a 1 in them. Those place values have 1s. So I would say 0010, 1000. Now here's a 75. So for 75, I would go down here. I'd start here with 128. Do I need 128? No, it's too large. Do I need a 64? Yes. If I have a 64, then I do 75 minus 64, and that's 11. That's all I need left. All I need is 11, so I don't need a 32, so that would be a 0. 16 would be a 0. I would use the 8. I put a 1 here, so 11 minus 8 is 3. And so I'd put a 0 here at the 4, use the 2 and the 1 to make the 3. So I would have 0, 1, 0, 0, 1, 0, 1, 1. And that's exactly what I have here. 0, 1, 0, 0, 1, 0, 1, 1. Okay, and I would do the same here for 131. Can I use 128 for 131? Yes. Once I do that, I subtract 128 from 131, and all I have left is 3. So I don't need a 64, don't need 32, don't need 16, don't need 8, don't need 4. But here's the 2 and the 1 to make 3. So for 131, I'd say 1, 0, 0, 0, 0, 0, 1, 1. And then finally, for 200 is another example. I would use 128, then I'd subtract 200 minus 128. And I think that leaves me with 72. And then I would use the 64. And all that would leave me left over after I use the 64, I would say 72 minus 64, and that would be 8. So then I don't need a 32, don't need 16. I'd use the 8, and then I wouldn't have any zeros for the rest of them. So I hope that helps. Please pick up the worksheet and practice. And that's it. Thank you.